Ready to begin? On behalf of the Center for Occupational Environmental Health, I would like to welcome you to the webinar, Heat Stress, Exposure Hazards, Health Effects, and Measurement Protocol, presented by Michael Strange, CIH. Michael Strange began his career as an analytical chemist at Fireman's Fund Environmental Laboratory. Then he worked as a field industrial hygienist under the direction of a certified industrial hygienist for the FPE group before becoming a CIH himself in 1990. He evaluates airborne chemical hazards, noise, radiation, vibration, and heat stress exposures to workers, as well as indoor air quality in office environments, manufacturing facilities, chemical, pharmaceutical, and medical facilities, agriculture, hospitality, construction, office buildings, and other environments. Currently, he is the principal consultant for Chubb Global Risk Advisors, assigned to the Pacific Northwest. However, he regularly practices internationally with experience in Australia, Europe, North Africa, Canada, and Mexico. Thank you so much for joining us, Michael. Are you ready to go?
Yes, I am. Can you hear me okay?
Yes, I can. Thank you so much.
Excellent. And thank you all for attending. I apologize about the technical difficulties. It's getting us started a little late. You know, I've attended several of these COEH webinars, and they've all been excellent presentation and very fine speakers. So it's both my honor and somewhat humbling to have this opportunity to make this presentation to you. I hope you'll find it useful. August is good timing for a discussion on heat stress hazards to workers. And as the summers get hotter, as the current climate change models indicate, workers indoors and outdoors will probably become more susceptible to heat-related illness as we go on. I promise you this is the most wordy and difficult to read slide that I'll show you. It's our attorney's disclaimer, and you're welcome to read that at your leisure. I do want to add that, disclose that I am an employee of Chubb Global Risk Advisors, and I've no relevant financial relationships to disclose. There's no financial in-kind commercial support for this activity. And I'd like to take this opportunity to give thanks to my colleague, Tony DiMaggio in Chicago. He developed the core of this presentation for his local section of the American Industrial Hygiene Association. I've made modifications to fit with this diverse audience today, but it was great to start with a good working model. So thank you, Tony. Today we're going to define heat stress, heat strain, and heat-related illness. And then we'll go into an overview of a heat stress and strain program. And it includes these four parts: where it's applicable, the heat stress assessment or measurements, heat stress controls, and awareness training. Heat stress is the net heat load to which a worker is exposed. All these factors contribute to the heat stress, both the physical exertion, environmental factors, and the type of clothing that's worn. And heat strain is the body's physiological response to heat stress, such as sweating, our primary method. The body uses evaporation to prevent its core temperature from rising to unhealthy levels. Evaporation of water is an endothermic reaction because the liquid water must absorb heat from its surroundings to change from its liquid state to vapor. And that's why we sweat, to cool the body by evaporation. We also have an increase in heart rate so that more heat can be transferred from the core to the skin where the blood is cooled. And when this pumping action and evaporation can't cool the body core fast enough, the result is a heat-related illness or even death. And here are the types of illnesses that can manifest, and we'll go through each one of these. The most serious illness is a heat stroke, and it's the most life-threatening. And the symptoms include hot, dry skin or profuse sweating, and they tend to have flushed skin. Nausea and vomiting, throbbing headache, high body temperature. There can be an altered state, mental state or behavior, and of course, rapid breathing and racing heart rate. So in terms of heat stroke, what can you do? if you think someone's experienced it, you need to get immediate medical attention. Call 911 or your local emergency services number. And then you need to take, while you're waiting for the ambulance, you need to take immediate action to cool the overheated person. And those would include getting the person into shade or indoors, remove excess clothing, cool the person with whatever means you have available. You can use a cold tub of water or a cool shower. You see a person on a stretcher here with ice, and you can cool with fanning and misting with water, even a garden hose on a mild setting, anything to get them cool. So here are the symptoms of heat exhaustion, and I'm going to bring back the symptoms of heat stroke so you can compare and contrast, because heat exhaustion can slip very easily into heat stroke. And you'll notice some of these symptoms are very similar and may just vary by severity. With heat exhaustion, you may see cool, moist skin with goosebumps, contrasting the heat stroke with hot, dry skin or profuse sweating. With heat stroke, the skin may be dry because the body's given up on evaporation as a means of cooling, so the core temperature continues to rise, and there's the danger. Flushed skin is another sign of heat stroke that's not typical of heat exhaustion. The faintness, dizziness, and fatigue might be hard to distinguish from altered mental state, as well as the pulse, nausea, and headache. So when in doubt, it's best to err on the side of caution and call an ambulance. So with heat exhaustion, you must stop all activities and rest, move to a cooler place, and drink cool water or a sports drink. One person should stay with you and watch for symptoms that could suggest you're slipping into heat stroke, such as unable to drink, becoming confused or agitated, losing consciousness, or running a high fever. And if you're showing these actions, go back to the actions I described for heat stroke. Don't worry about remembering these details, because later in the presentation, I'll show you an excellent free phone app, so this resource can always be with you. Heat cramps are painful involuntary muscle spasms that usually occur during heavy exercise in hot environments. They may be more intense and prolonged than the typical nighttime leg cramps. And fluid and electrolyte loss often contribute to the syndrome. So what you could do is rest briefly and cool down, drink a clear juice or an electrolyte containing sports drink, practice gentle range of motion stretching and gentle massage of the affected muscle groups. And don't resume strenuous activity for several hours or longer after the heat cramps go away. And if they don't go away within an hour or so, that's when you should see your doctor. So let's talk about heat syncope and exercise-related collapse. Heat syncope is a feeling of lightheadedness or fainting caused by high temperatures. And it often occurs after standing for a long period of time or standing quickly after sitting for too long a period of time. Exercise-associated collapse is feeling lightheaded and fainting immediately after exercising, especially if you immediately stop running and stand after a race or a long run. For heat rash, it's also known as prickly heat or miliaria, and it affects adults as well as babies, especially during hot, humid weather. Heat rash develops when the blocked pores or sweat ducts trap perspiration under your skin. So it tends to develop in skin folds where the clothing causes friction. Symptoms range from superficial blisters to deep red lumps. And some forms of heat rash feel prickly or intensely itchy. Heat rash usually clears on its own. Severe forms of the condition may need medical care, but the best way to relieve symptoms is to cool your skin and prevent sweating. The types of miliaria are classified according to how deeply the sweat ducts are blocked, and the signs and symptoms for each type vary. Miliaria crystallina is the mildest form, and it's marked by clear fluid-filled blisters and bumps or papules that break easily. Miliaria rubra occurs deeper in the skin, and the signs and symptoms include red bumps and itching or prickling in the affected area. Occasionally, the fluid-filled containing sacs, the vesicles of miliaria rubra, become inflamed and pus-filled, and this form is called miliaria pustulosa. And the last one is less common. It's miliaria profunda, where sweat leaks out of the sweat glands, but still retained in the skin, and it causes firm, flesh-colored lesions that resemble goosebumps. Heat rash usually heals by cooling the skin and avoiding further exposure to the heat that caused it. Then you should see your doctor if you or your child have symptoms that last longer than a few days. If the heat rash seems to be getting worse, or if you notice signs of infection, such as increased pain, swelling, redness, or warmth around the affected area, pus draining from the lesions, swollen lymph nodes in the armpit, neck, or groin, or fever or chills. There are many factors that contribute to the risk for heat stress related illness, and I'd like to go over these. Obviously, high temperature and humidities are factors, as well as direct sunlight. If you have indoor radiant heat sources like furnaces, and if there's limited air movement indoors or outdoors, if you're not intaking enough fluid, that's an increased risk of heat-related illness. Physical exertion, personal protective equipment and clothing, and it's also based on your physical conditions or any pre-existing health problems. Your medications can make you more susceptible to heat stress, pregnancy, a lack of recent exposure. If you're not an acclimatized worker, you're at greater risk for heat-related illness, advanced age, or if you've previously had heat-related illness. A heat-related illness prevention program is most effective when management commits to identifying and reducing exposure to the hazards. The program should establish how to determine if workers are exposed to a heat hazard based on these environmental conditions. And we've established tools for doing that. The program should also include procedures to control and hopefully minimize the heat hazards. So the four key aspects of the heat-related illness prevention program I mentioned earlier. It's where it applies, applicability, the heat stress assessment, measurement, what you do to control the heat stress issues, and awareness training, very important. And we'll go through each of these. The program is applicable where the temperatures may exceed the action level. Federal OSHA has a heat stress guideline, but not a regulation. They can and do cite under the general duty clause, but it needs to be a clear and imminent hazard. And we've seen earlier how the consequences of a heat stress exposure could be very severe. In California, we do have a heat stress regulation in Title VIII, and Minnesota and Washington State have also adopted standards. In California, Cal OSHA requires employers to provide shade at an ambient level of 80 degrees Fahrenheit. When temperatures reach 95 degrees or above, Cal OSHA requires the employer to ensure that employee takes minimum 10-minute cool down rest periods every 2 hours. The action limit does not apply to infrequently performed light to moderate work tasks of short duration, like 15 minutes or less. Contractors also have to have their own heat stress prevention program and implement that program for their work activities. When the action level is exceeded, heat assessment needs to be done. And if control measures are implemented, a reassessment is needed to make sure they've been effective. And here are three methods that you can use. The best method is a direct reading instrument to measure the wet bulb globe temperature. There are units you can purchase, but I usually rent one for about $65 a day. That way we don't have to get them calibrated annually for an instrument I may only use a few times a year. The rental company does the calibrations and they can give you a certificate. And we compare these results to the ACGIH TLV and action limit. And I'll show you an example of that too. You can also estimate heat loads using your local weather forecast. It'll give you the dry bulb temperature and humidity. And this is only applicable if the outdoor weather conditions are representative of those in the workplace. Usually they're not. If you have interior heat sources such as furnaces or a lot of machinery, you really need to get indoor measurements. And I'll also show you a heat stress calculator screening tool. A wet bulb globe temperature is a heat measurement used by ACGIH and NIOSH. NIOSH is the National Institutes for Occupational Safety and Health, the research arm for OSHA. So it's based on the dry bulb temperature, the wet bulb temperature, and the globe temperature. The wet bulb is the center probe with the wick. With this older model, you have to put distilled water in the reservoir to keep the wick wet. The newer models use internal probes. So the ambient temperature, the dry bulb, is the far right probe, and the radiant heat or globe temperature is measured in the black globe. And here's what that relationship looks like mathematically. Here are the formulas for the calculation for wet bulb globe temperature. Now, I just provide these to demonstrate the mathematical relationship. I haven't need to calculate these numbers since I took the CIH exam. The instruments give you the wet bulb globe temperature value exactly. You just need to know whether it's with direct sunlight to exposure to the sunlight, which is the out measurement, or without direct exposure to the sun, called the in. This is a table from the TLV booklet under the category of heat stress. It lists the clothing adjustment factors that you add to your wet bulb globe temperature measurement. There's no adjustment for standard work clothes or cloth coveralls. 3 for double layer woven clothing. You add half a degree for SMS polypropylene coveralls. The SMS is a special type of material that provides a combination of breathability. It's somewhat porous. At the same time, it provides protection from paints or liquids, sprays or powders or whatever you're protecting from, as compared to the polyolefin coveralls that are less permeable to air. There are also limited use vapor barrier coveralls with a protection factor of 11. Now, it's note that none of these, there's no value for level A fully encapsulated suit. It's just not assigned a value. And that doesn't mean it's not zero. In fact, it's quite the contrary. They will insulate the body heat. Oftentimes, this is mediated with cooling from supplied air respirators or SCBAs, and we'll show you later some of the other ways to cool a person inside these barriers. Now, all of these values assume that only modesty clothing is worn underneath, no street clothes. That would make the factor higher. So you add your clothing factor, 0, 11, to your wet bulb globe temperature measurement, and you then compare it to the appropriate TLV value of Table 2. The horizontal component demonstrates the percentage of time spent at work compared to the amount of time at rest in cool environments. The vertical value is the level of exertion required for the work, and that contributes to the metabolic heat load. So if you have light work at a 75 to 100% work-to-rest ratio, the TLV is 31 degrees centigrade, and the action level is 28 degrees centigrade. And you can see as you go higher in the wet bulb globe temperature, your time working needs to become less, and the rest periods need to become longer. Heavy and very heavy work involve physiological strain, and there are no criteria developed provided for continuous work. Very heavy work is also excluded for the 50 to 75% range. So as the work demand increases, as I said, so does the metabolic rate, and here are some of those values. Consequently, these values in the table decrease. The criteria values in the table decrease to make sure that most workers will not have a body core temperature greater than 38 degrees centigrade. And table 3 estimates that metabolic rate in watts. And we'll use that later in the, we'll use that next. This table is from, this worksheet was by Thomas Bernard of the University of South Florida College of Public Health. And it is available on his website. And I'll bring it up here too. I put in some numbers as an example. Here are our wet bulb globe temperature measurements over various tasks throughout the day. And I've assumed an increasing temperature. And the last column is all the rest breaks put together. And I'm assuming a break room at 20 degrees centigrade, and an hour a day would be 2 15-minute breaks and a half-hour lunch period. So this is the most basic, 75 to 85. 75 to 100.
Michael, just going to interrupt you for just a moment. It looks like we're actually not seeing the Excel window. I think you might have shared the PowerPoint and not the Excel. Just wanted to let you know.
Yes, I appreciate that. I could stop share and then bring up the worksheet. Should I try to do that?
Yeah, go ahead. That way people can see what you're looking at there.
I just hope it doesn't knock me out again.
And then if you want to share the full window, that should help. Perfect. Now we can see it. Thank you, Michael.
Okay, thank you for pointing that out. So anyway, I won't go back to the beginning because you did see those numbers in the PowerPoint, right? What we were pointing to? Actually, no, because you didn't see my, my cursor move. So I've assumed wet bulb globe temperatures over 5 different tasks of the day. And this last column is the rest period in a 20-degree centigrade room, assuming 2 15-minute breaks and a half-hour lunch period. So each of these where I've assumed a metabolic rate, it's assigned that metabolic rate in watts. And then we have the standard work clothing. And what happens at the top, the effective wet bulb globe temperature for the day is just above the TLV by about 1/10 of a percent. You want to be not only below the TLV, but you want to be down at or below the action level, preferably below the action level. So there's some things that you can do to moderate this. Let's say that you put under the heavy work task, why don't you put a second person in there, cut the time in half, and then add that time over to the rest break. And that brings you even further down below the TLV. Still doesn't get us quite down to action level. But as you can see, you can work with those numbers. You can also, a better solution would be to try to reduce that temperature in some way, more cooling and so forth. But you can see how the tool works. So let me get back to the presentation since we started a little bit late here. Wait, it didn't go back. Back to that one. Oops. There it is. Okay. Okay, you seeing the presentation again?
Yeah, yes, we are.
Okay, yes, okay, good. So let's look at a real world example here. In late June 2018, I went to a chemical dispensing facility in Arizona where they package inorganic acids such as hydrogen fluoride, also alkali and peroxides and so forth. It's in an air-conditioned building, so you might expect that the ambient heat levels are likely to stay below action level. But, and that pretty much is the case in terms of just the standard reading with no clothing adjustment. But let's say that you had to put on one of those full vapor barrier suits for hydrogen fluoride. That would have to add a clothing factor of 11. And in almost all these cases, both indoors and outdoors, that puts us over the action level, if not over the TLV. Now, this is a gross overestimation of the exposure because they don't package hydrogen fluoride all day for a whole shift. But the workload does fluctuate depending on what supply orders they're getting. So we assume the worst case. And also we're assuming the 75 to 100% rest cycle. I'd like to call your attention to graphs, oops, go back. To the graphs A3 and A4 here. And you'll see that in the basic dispensing room with nothing happening, you got the very low temperatures. If you add the clothing adjustment of 11, you get this. A4, I had asked the worker to wear the heat stress monitor on his, well, he was wearing street clothes under his coveralls, and he put the monitor in on his belt and between the street clothes and the vapor barrier coveralls. He was a good sport. And he worked in there for about an hour, and look what happens with the results. The low end of the measurement is pretty much what we predicted for the empty room. But look at the high end measurement is more than 11 degrees hotter. And there could be a couple of reasons for that. One is the fact that he was wearing street clothes and it doesn't apply. And the other is he was working very fast. And so he might have slipped from moderate work to heavy work. So you kind of have to go back and forth with your definitions based on what you see in the field and what the numbers show you. Two of my recommendations for this site was that they change out of street clothes before donning the vapor barrier coveralls, and decrease the work versus rest time to 50 to 75%. Now for the peroxides, the alkalis, and the other chemicals, the PPE is really not a problem because it's either a cloth coverall or it's or paper coverall, or it's a protective aprons. I want to call your attention also to the outdoor mix platform. Here are the measurements early in the morning, and the standard shift is 5 to 1:30, and that lets them get out before the heat of the day in the summer. In the wintertime, it goes back to a different kind of hours. And if you notice at the last measurement, you can see that even the ambient temperature out on that mixed platform was above the action level. And you add clothing to that and it's substantially higher. So I wanted to show you those dispensing room results graphically. In the top graph is the data logging readout of the heat stress meter in the dispensing room with no work going on. And you can see the temperature ranges from 14 to 21 degrees C. The lower scale down here goes from 24 to 16. And this is the monitor when it was inside the worker's coveralls. And you can see that, first of all, the humidity is really high. His clothes are really drenched when he got out of there. And you can see that the heat index went incredibly high, the temperature plus the humidity. So that demonstrates the effect of the heat and the clothing. So the goal of the TLV is to keep the body core temperature below 38 degrees. And so what do we do with these wet bulb lobe temperature readings? If you go down the chart, if you anticipate heat stress, the first thing you look is the clothing. Does it allow air movement? And then the next step down, do you have screening criteria? Is the screening criteria of table 2 exceeded? In other words, are you above the action level? And if it's yes, you go down into, is there data for detailed analysis that indicates heat stress? And if, is there data available? And if there's yes, then you go down to excessive heat stress based on detailed analysis. If not, I mean, so you perform the heat strain physiological monitoring. And if you find that there's excessive heat strain based on the monitoring, you implement job controls and then go back and go through the reassessment again. Again, this is right out of the TLV booklet. Your weather forecast allows you time to prepare for forecasted heat waves, but keep in mind too that the outdoor conditions might not represent indoor. For example, if you have a large metal fabrication shop with open windows and rolled up doors, but no air conditioning, all it can really help you do is anticipate hotter overall conditions in your region. Weather underground, same thing. It could give you historical data for any city and also the daily forecast. NIOSH and OSHA have developed this screening tool app, which takes the local weather conditions, the dry bulb and relative humidity, and it determines a combined heat index. The heat index is higher when it occurs when high temperatures occur with high humidity, and lower when they occur with lower humidity. And the heat index is based on studies of skin cooling caused by evaporation of sweat. The heat index is a number that represents the effect of temperature and humidity on humans by combining the two variables into an apparent temperature, like 90 feels like 112. It also has handy tabs at the bottom here that cite the symptoms of different heat illnesses that I described at the beginning. And it has a tab for first aid instructions for each heat illness. When you're in that stressful situation, trying to observe someone's symptoms, this is a very handy tool to have right at your fingertips. The knowledge can help keep you calm. And best of all, it's a free app. What the OSHA NIOSH app doesn't do, again, is give you the heat index value in the work area itself. Just, such as the large metal fabrication shop or outdoors where the agricultural workers are working in the fields. I would like to show you another screening tool that's based on these four agencies listed here. The tool is based on heat index and also considers worker acclimatization, clothing, PPE, workload, and solar load. But before we get there, let's talk about issues of acclimatization and other factors. In terms of a quick and easy heat stress measurement tool, there's a sling psychrometer, which is a good manual tool. It has two thermometers, a wet bulb and a dry bulb that you spin in the air while you're holding the handle. And then you take the wet and dry bulb readings together and it gives you the relative humidity in percent. There are also electronic versions of this, but they should be calibrated annually by the manufacturer. And if there's a phone app for this, I wouldn't trust it. I was once with a customer who bought a sound level meter app. And when we did side-by-side measurements against my calibrated sound level meter, his result was just as much as 10% off in some cases. And that's huge on the logarithmic scale. So, if it's not calibrated, if it's not a calibrated instrument, it's just not a real reading. So when we measure the temperature and relative humidity, then we need to know if the workforce is acclimatized to the hot environment. And an acclimatization program, when it's properly designed and applied, it decreases substantially the risk of heat-related illnesses among employees. And it involves exposing employees to work in the hot environment for progressively longer periods. If you have workers that have had previous experience in jobs where the heat levels are high enough to produce heat stress, the regimen should be 50% exposure on day 1, 60% on day 2, 80% on day 3, 100% on day 4. And it's also important to add that previous experience needs to be recent because you can lose the acclimatization. For new workers, it's no more than 20% on day 1, no more than 20, with a daily increase of no more than 20% per day for 5 days. And also, as I said, the the loss of acclimatization can occur when you're no longer exposed. It usually becomes noticeable after 4 days and may be completely lost after 3 to 4 weeks. And then you need to start from the beginning again. And so next, just like with the TLV comparison, we evaluate the impact of clothing, flame retardant clothing, and personal protective equipment. And we also evaluate the level of the physical workload, just like we did in the other example. And what we come up with when we place all these factors into the tool, we wind up with a number that gives us the relative risk level, from no adverse impact expected, all the way up to high risk where a heat stroke could be likely without controls. And we'll go back. Okay. Here's the other example that I showed you of a heat stress tool, and that will use this heat index formula. So let's take, for example, you have an ambient outdoor temperature, or a rook area temperature, excuse me, of 90 degrees. And let's say it's 50% humidity. Assuming we have a acclimatized workforce with light or no thick garments, normal exertion, and no direct exposure to sunlight, we have a heat index of 96, which puts us in a low risk category where the heat stress, heat exhaustion, or cramps are possible. If, just to see how the numbers go, let's say you have a non-acclimatized worker. Well, you add a factor of 10, and it raises you up to 106, which puts you into that medium category where those heat cramps and exhaustions are likely, and heat stroke possible. And so let's just add some more and see what that does to our heat stress settings. Full body chemical protective suit adds another 10. If you have strenuous work, heavy work, it's a heat adjustment of 5. And let's say there's direct sunlight, takes you up to 15. And that brings you down to 136, which puts you in the very high risk category. And so there have to be some cooling effects measures taken. And I'll show you what some of those are. Okay. Let's see. Okay, yeah, there's the tool. Okay. Okay, next, if the heat stress calculator tool gives you very borderline results, then you should probably do a more detailed analysis of the direct reading wet bulb globe temperature measurements. And even then, you have to consider that the TLV and action levels are estimates that are reasonably expected to protect most workers. And there is also the option of doing physiological monitoring directly to see if a worker is having a response to heat stress. You can measure it right on the person. I'll tell you right now, there's not a very easy, workable technological tool for that. We have been experimenting with a number of them. Here are some of the physiological monitoring parameters that we can look for. And if you're below these numbers, then it indicates an acceptable management of your heat stress exposures. Again, you want to consider extremes and less tolerant workers. But basically, they should be discontinued if the heart rate is over 180 beats per minute, minus the individual's age and years. If the core temperature for acclimatized or unacclimatized worker is excessive, or the recovery heart rate at 1 minute after peak work effort is greater than 120, or if there are those symptoms of sudden and severe fatigue, nausea, dizziness. Now, at that same chemical packaging facility in Arizona, where I did the area wet bulb monitoring, I also asked workers to wear probes that would monitor their body temperature all day long. The probe is designed as an earplug that's wired to a data logging device that a worker wears on the belt. The probe measures the temperature inside the ear and compares it to the temperature inside the mold. A temperature differential of more than 10 degrees centigrade means that the earplug fit is compromised, and therein lies the problem. Unfortunately, the earplug is so big that only people with very large ear canals can keep them in. And in fact, this instrument has been discontinued by the manufacturer, although most of the IH rental companies still have them and you can get them. As you can see, the temperature ranges that are shown here, were not really very helpful. And it was full of caveats because of the earplugs getting loose or losing their good fit. And at the end of the day, all the employees complained of sore ears. But just to show you a couple of graphs, here's one. The blue line represents the ear temperature by the probe. And then the dark green line means the temperature inside the mold. And you see the first worker on the top here had a really hard time getting any kind of seal. He would jam it in here, it'd only go up a couple of degrees, and it would kind of get looser again. And he kept working with it. And finally, for about the last, about half the morning, we had reasonably usable data. But as you can see, the temperature, we're reasonably confident that at least during this period, he didn't have an excessive core temperature. And the same thing is true of this worker, but he had more at the bottom, but he had more success in terms of keeping the earplug inside his ear. So I'm hoping that somebody will come out with a model that is a better fit, because this is a good way to monitor temperatures through the day. The other thing is the probe issues a small alarm if your body temperature rises above core. Unfortunately, it also issues the same alarm if the earplug fit is loose. So it's just not very reliable. Which, we've also been experimenting with exercise monitors to check pulse rates, but I myself had disappointing results with it. I actually, with the model I tried, I actually got better results with my Fitbit in terms of measuring pulse rates. So for now, the best system I see for physiological monitoring is the buddy system and watching for signs and symptoms of heat stress. A person might be at greater risk if you see them profuse sweating is sustained over a number of hours. Weight loss can also make one more susceptible, and you can also do a urinalysis for sodium. So again, that makes it even more critical that supervisors and workers are trained to recognize the symptoms of heat-related illnesses and what to do about it. So let's talk about the hierarchy of controls. In industrial hygiene, the hierarchy is the best level of control is elimination of the hazard, the chemical or the heat or what have you. When you can't do that, you go to engineering controls, and next is administrative controls, and finally is personal protective equipment. So with elimination controls, you can modify the hot process or operation to a lower temperature. With engineering controls, if you have a high surface temperature, you can reduce that surface temperature or shield the worker from it using some type of insulating or reflective material. With convective heat, you can modify air temperature and or the air movement. With evaporative heat, you can decrease ambient humidity, minimize excess moisture sources where possible, and increase the air movement. In terms of administrative controls, you can train and educate workers and supervisors on risk factors and early warning signs of heat stress. And this you need to do if you have a heat related illness program, prevention program anyway. You need to train and educate the workers. And if you can schedule very hot jobs on cooler part of the day, like in my example where they started the shift early during the summer. You can schedule routine maintenance and repair work in hot areas during cooler seasons where the risk of heat stress would not be so severe. You can shorten the duration of exposure, reduce the workday time, increase rest breaks, and restrict overtime. If you can create shorter but more frequent work rest cycles, that provides the greatest benefit to the employee. And where possible, the breaks should be taken in an area that's cooler than the work environment, such as an air-conditioned break room or in the shade. And the rest area should be close to the work area. You need to allow unacclimatized workers to break in slowly and rotate workers or tasks where you can. And the use of the buddy system where employees work with another employee or a small team and they can observe each other for early signs of heat stress. Other administrative controls, you can require workers freedom to interrupt their work when they feel extreme heat and discomfort. You can reduce metabolic demands of activity by mechanical methods, specialized tools or equipment, or increase the number of employees doing the task. And this is very important. You need to ensure that there's adequate fluid replacement. There should be at least 5 to 8 ounces of cool water every 20 or 30 minutes, whether the person is thirsty or not. Thirst should not be the trigger. And of course, individual drinking cups must be provided, especially in today's COVID. But that was true of before COVID too. Use of electrolyte replacement fluids is good, but the use of salt tablets is prohibited. So what can you do for personal protective equipment? Well, there are cooled fluid or ice-cooled clothing or air-cooled garments that are available, especially if you're under heavy protective gear or fully encapsulating suits. You can wear absorptive or evaporative cooling clothing. It's wetted cloths over garments such as terry cloth or cotton when you have impermeable clothing. You can use reflective clothing or aprons to reflect the heat. Oops. I don't know why the chat came up. And you can wear broad-brimmed hats and lightweight clothing to reduce direct exposure to sun. And again, the heat stress awareness training should include training to all affected employees on assignment and annually after that. They need to be trained on heat stress and its potential effects on their life and health and factors that contribute to heat stress. It's a lot of material. The importance of early recognition of heat stress and the signs of symptoms of heat-related illnesses. You want to teach them about emergency response to heat stress, first aid measures, or treatment as early as possible. You need to teach them about predisposing factors that increase an individual's susceptibility to developing heat stress and take extra precautions for that person. And generally precautions for working in heat stress areas, including acclimatization. How to properly use and take care of heat protective clothing and equipment if you're using that. And these are the references that we use to put together this, this program. And I actually forgot to include the Mayo Clinic on that one. I'll have to go back and replace that. Do we have time for questions?
Yes. Hi, this is Jessica, and I went ahead and let everybody know that we'll try to answer a few questions. Michael, if you want, we can go a little bit past 1 o'clock if you have time, but we can answer what we can. So go ahead.
I said it's all right with me to go a little over time.
Okay, great. So I'm just gonna go through some of the questions. If it is something that, some of these are from earlier in the presentation, so if you've already answered it, you can feel free to let me know and we'll move on to the next one. If anybody has any questions, if you can put them in the Q&A box and I will try to get to them. So one of the first questions during the presentation was, what are the ramifications of the rejection of the use by OSHA of the NWS heat index?
I wasn't aware of the of OSHA's rejecting the heat index program. I didn't quite get. I don't think I quite got the question.
Yes, if the person who wrote the question would like, Paul, if you can maybe write a little bit more about that, I'll come back to that in just a second. The second question, do any insurance companies provide services to assess and prevent heat-related illness and productivity loss in indoor workplaces that you know of?
Oh, yes. Yes, we are one that does it. Our parent company is Chubb Insurance. We're a division called Chubb Global Risk Advisors. And other IH consulting firms do it as well.
Great, thank you. And also in the chat, I just want to let you know that one of the participants said that a judge actually overruled OSHA on using the heat index in a very recent decision.
Ah, okay.
So on to another question. Does the Department of Defense heat illness prevention policies meet Cal OSHA requirements? And on a side note, this person heard that the Navy personnel working outdoors in the Middle East were required to take cooling and hydration breaks. To cool down, they went indoors and laid on concrete floors for 15 minutes or more.
Wow. I don't want to be too quick to answer this, but it's been my understanding that Cal OSHA doesn't, state OSHA programs don't have jurisdiction over the military. I may be wrong. That may be federal OSHA does, but I would like to get a list of these questions, and I'd like to research that one before I commit to an answer on it.
Great, and I can give you a copy of these later on for you to go ahead and look into. Another question is, what is your evidence-based research on giving sports drinks? They would like to know, what about victims who may have medical conditions such as diabetes or other issues? The individual thought that the recommendation was to give water and not drinks that contain sugars or substances that may cause the symptoms to be increased.
Well, certainly in a diabetic situation, yes. And I believe that diabetes would be a condition that could predispose you to a higher heat stress hazard. In terms of the sports drinks, that recommendation was through the Mayo Clinic, and I would have to do further research to see what the evidence base on those recommendations are.
Great, thank you. Again, another update in the chat box. One of our viewers said that you are correct. The military falls under federal OSHA.
Thank you. Got to have a fact checker.
Yes, everybody's helping. We have so much
Yes.
information and so much expertise even among our audience.
Oh, this is a fantastic group. I love attending these webinars.
Thank you. I'm so glad. Okay, so the next question is, are many employers and employees from your perspective, are they using the NIOSH heat app that forecasts hourly heat index or indices?
I'm really not sure. I've demonstrated it to a number of clients who weren't aware of it before. So, the site EHS people, they are all over the board in terms of experience and knowledge. So I would say probably some are and some aren't.
Great, thank you. In the chat box, for the record, I just added a comment from one of our viewers that says the information for the federal OSHA USPS case regarding the NWS heat index. The link is now in the chat if anybody needs that.
Oh, good. Thank you.
Okay, so let's see. The next question. Let's see. Do you have, have the heat stress TLVs changed over the past 30 years? Back then, the TLVs were judged, it's judged by my organization to be infeasible for the maintenance workforce at the oil refinery that the viewer was working at in the tropics, because they permitted almost no work to be done during the summer. What are your thoughts about that, and if there's been change there?
Well, the TLVs are guidelines, and there's so many different chemicals and everything has changed over the years that's another one I would need to research how long this particular set has been now, you know, at these levels. I don't
Okay.
recall a recent change, but my memory doesn't go back 30 years. I'm sorry.
Okay, and I do have a couple of questions that are maybe a little smaller questions for you, but I'll go ahead and just ask all three. One user wanted to know if there's any relation between heat stress and dehydration. Another, two questions about the clothing. One was asking how many degrees that you would add for FR rated clothing and maybe what an explanation of double layer woven clothing is.
Okay. Go back to the first one.
Yes, so is there any relation between heat stress and dehydration?
I'd say it would be the other way around. I would say that dehydration would make you more prone to heat stress because your body's just not, you know, producing enough perspiration. And then the second was about the clothing, or was that
Yes.
the third?
So how many degrees would you add for FR rated clothing? And then just exactly what is double layer woven clothing for a viewer just wanted to know.
Okay. I'm just glancing and see if it's in the TLV booklet here. And I may need to go back to the documentation of the TLV.
Okay, and I can also let, if that falls into resources, then I'm sure that the attendee could maybe look that up in the future.
You know, and you were talking about the work in the tropics in oil refineries. You know, again, this is just going to get worse as the global temperatures continue to rise, both in the tropics and in the desert and up here.
Absolutely.
So that's an issue. They're not going to raise the TLVs to accommodate that. My advice would be to go with the controls. You know, cool them down with ice vests and more frequent rest breaks in a cool area. That's all I could suggest.
Thank you so much. I'll go ahead and move on to the next question. I know we're pushing time, but I'll probably try to answer 2 or 3 more questions or have you answer.
Okay.
So one of the users was asking if you've seen many heat stress problems with firefighters. This user heard from a Northern California volunteer fireman that they have had several young male volunteers need heart defibrillation due to consumption of Red Bull, working hard in full gear in hot weather, and experienced tachycardia. What are your thoughts on that?
That does not surprise me at all. I have not done any work directly with firefighters, but I can certainly imagine that situation. First of all, you have the heat of the flame, and then also the fire is happening during the summer season when the ambient temperatures are hot too. So I can see that being a real problem, and they really need to have a robust not only heat avoidance system, but emergency rescue system.
Great, thank you. And again, another update from the audience with regard to the tropical climates. One of our CIHs wrote that wind speed in tropical climates can also reduce the risk slightly in those tropical areas.
Even the movement of hot, moist air, huh?
We'll see.
Yeah.
Okay, so we have another question I think is a good one, but there are several types of common medications and medical conditions that increase sensitivity to heat stress. Do you know if any of the calculators or other methods can help adjust for these factors?
Not off the top of my head, but I can do some research on that.
Okay, great.
In fact, I'll research all the questions, even the ones that you haven't been able to read out.
Absolutely, and I'll go ahead and send those to you after. So I'm just looking at some of these questions that we have in here. Good. Okay, so I'll just ask one final question, and it's how would you objectively assess workers prior I can't say that word.
Acclimatization.
Thank you. That word, before subjecting them to different regimens as pointed in presentation for those with prior and those without?
I think it really comes down to the interview. and ask them, about their experience working in hot environments and for how long. In terms of physiological measurements, that's something I can research as well.
Great, thank you so much. And I really appreciate you taking the extra time out to answer some of these questions. There were so many. I'm sorry if we didn't get to yours. That said, we will make sure that there are resources, and the recording will be available. I just wanted to thank you, Michael, for this great presentation. It's so relevant right now. And thank you to everyone who joined us for today's webinar. Be sure to check out our website for more information at coeh.berkeley.edu/aboutce. As a reminder, an email will be sent out tomorrow afternoon with the webinar recording and evaluation link for all of those who logged in with their registration emails today. Thank you so much for all these wonderful questions and your participation, and I hope everybody enjoys the rest of their day. Thank you, Michael.
And I will certainly, and I will add that all of your questions will be read and addressed one way or another.
Yes, and thank you guys so much for all of your input.